Dear grade 12 student, in this video we are gonna talk about the cross product and determinants, the collinear vectors, the area of a triangle, and finally the area of parallelogram. Let's start by the cross product. The cross product of two vectors u and v is defined only in three-dimensional space and is denoted by u cross v. It's perpendicular orthogonal to both u and v with a direction given by the right hand rule. So, in the space of referred to a direct orthonormal system OIJK, let u and v be two non-collinear vectors. The vector cross product of u and v denoted by u cross v is a new vector w, where w is orthogonal to u and w is orthogonal to v. Then the cross product of u and v, the vector w, is perpendicular to the plane containing u and v. The norm of this vector w is defined by norm of u times norm of v times sine the angle between u and v. Now let's talk about some properties. For this, take three non-collinear vectors u, v, and w and let alpha and beta be two real numbers then. The cross product is anti-commutative. It means that u cross v is not equal to v cross u, it's equal to minus v cross u. As shown in this figure, we have two vectors a and b, then the cross product of these two vectors denoted by a cross b is the opposite vector of the cross product of b cross a. The cross product is distributive over addition. It means that u cross v plus w is equal to u cross v plus u cross w. With scalar, the vector alpha u cross v is equal to u vector cross alpha v is equal to alpha u cross v. The vector alpha u cross the vector beta v is equal to alpha beta times u cross v. The standard basis vectors I, j, k satisfy the following equalities in a right hand and coordinate system. Then I cross j is equal to the vector k, and j cross k is equal to the vector I, and k vector cross I vector is equal to the vector j, and j vector cross I vector is equal to minus k. Use the anti-commutative rules. And k vector cross j vector is equal to minus I, and finally I vector cross k vector is equal to minus j. Now let's talk about the analytic form of vector product. Use determinants. For this, take the two vectors u and v defined by their coordinates a, b, c, and alpha, beta, gamma, and let w vector be the cross vector of u and v. Then, to find the cross vector of u and v, put them in the form of a matrix starting by I, j, k, the corresponding vectors of the axis x, y, z, and put in the middle the vector u, since that become at first, and finally the vector v, which is alpha, beta, gamma. We install the first column and the first row, and we leave b, c, beta, gamma. We get I, determinant of b, c, beta, gamma, minus, we install the second column and the first row. We leave a, c, alpha, gamma. We get minus j, determinant of a, c, alpha, gamma, plus we install the third column and the first row. We leave a, b, alpha, beta. We get determinant of a, b, alpha, beta. apply the determine rule, then it's equal to I B times gamma minus beta times C minus J vector A gamma minus alpha times C plus K vector A beta minus alpha B. And these are the coordinates of the vector W. An example about this, take the vector U equals 3I plus 2J minus 5K and the vector be defined by its coordinates minus 1, 5, 3. The question is to determine the cross vector W and calculate its norm. To find the cross vector W, put them in the form of matrix starting by I, J, K and U in the middle and V, and apply this rule. And store the first row with the first column and leave this determinant equal to I 2 times 3 minus 5 times minus 5 minus J, and store the second column with the first row. We leave the determinant 3 minus 5 minus 1, 3, we get 3 times 3 minus 1 times minus 5 plus K vector. We install the first row by the third column. We leave the determinant 3, 2 minus 1, 5. We get K vector 3 times 5 minus 1 times 2. And by calculation we get the vector W is equal to 31I minus 4J plus 17K. Then the vector W is 31 minus 4, 17. Now finding the norm of the vector W, apply the rule of the norm. Radical x squared plus y squared plus z squared. Replace x, y, z by their values and we get the norm of W is equal to radical 1266 unit of length. Now let's talk about collinear vector. Two vectors are collinear, then they having same direction. In this figure, we show that these two vectors are collinear, having same sense, and these two vectors are also collinear but having opposite sense. We have many methods to prove collinear vectors. For this, take the two vectors u and v, where x, y, z are the coordinates of u and x prime, y prime, z prime are the coordinates of v. First method, u and v are collinear if x over x prime equal y over y prime equal z over z prime. We use this method only when x prime, y prime, z prime are different than 0. Second method, u vector and v vector are collinear if exists a constant k belong to R not equal to 0, such that u vector is equal to k times v vector. By example, if a u vector defined by the coordinates 2, 0, 5 and v by minus 4, 0, minus 10, we see that the vector v is equal to minus 2 vector u. Then u and v are collinear. Third method, u and v are collinear if the cross product of u and v equal to 0. Remark, if A, B and AC are collinear, then A, B and C collinear points since they have a common point A. Now let's talk about how to find the area of triangle using cross product. For this, take a triangle ABC, then the area of this triangle ABC is defined by the half of the norm of the cross vector of two vectors of the triangle ABC, take by example the vector AB cross the vector AC. Let's prove this. Take the triangle ABC and let H be the orthogonal projection from C to AB. We know that the area of triangle ABC is equal to the height times base over 2. Then it's equal to CH times AB over 2. Let's find the quantity norm, half of the norm AB cross AC. Use the geometric definition of the cross product. It's equal to norm half times norm of AB times norm of AC times the sine of the angle between the two vectors AB and AC. It's the angle CAB, and we know that the sine of the angle CAB is equal to the opposite side over the hypotenuse. Then it's equal to CH over AC. We can simplify by AC and AC. We get finally the norm, the half of the norm AB cross AC is equal to CH times AB over 2. An application about this: consider the triangle ABC whose vertices A defined by its coordinates 1, minus 1, 2, and B defined by coordinates 2, 1, minus 1, and C defined by its coordinates 3, minus 1, 2. First question is to calculate the area of ABC, and second question is to calculate the distance from C to AB. Solution. Area of triangle ABC is equal to the half of the norm of the cross product between the two vectors AB and AC. First, finding the coordinates of AB and AC, and calculate the cross product of the vector AB and AC. Put them in the form of a matrix, starting by IJK, AB in the middle and AC, and by calculation we get that AB vector cross AC vector it's equal to minus 6J minus 4K. Then we need to calculate its norm of AB cross AC. It's equal to radical minus 6 square plus minus 4 square. It's equal to 2 radical 13. Then the area of the triangle ABC is equal to half this norm. It's equal to radical 13 units square. Second question, we need to calculate the distance from C to AB. For this, take H, the orthogonal projection from C to AB. Then the distance from C to AB, it's CH. We know that the area of the triangle ABC is equal also to the height times base over 2. It's equal to CH times AB over 2. Replace the area of ABC by its quantity radical 13, and calculate the length of AB is equal to radical 14, and by cross multiplication we get CH. Now, how to find the area of parallelogram? Use cross product. The area of a palm ABCD is defined by norm of the cross product of the vectors AB and AC. For this, take a palm ABCD and let H be the orthogonal projection from B to AB. Then, we know that the area of palm ABCD is height times base. Then it's equal to BH times AD. Let's prove that the quantity norm of AB cross AD it's equal to BH times AD. So, for this, norm of AB cross AD is equal to the norm of AB times norm of AD times the sine between these two vectors. It's sine of the angle DAB. And we know that the sine of this angle is equal to the opposite side over the hypotenuse. It's equal to BH over AB. Then norm of AB cross AD is equal to AB times AD times BH over AB, and we can simplify by AB and AB, we get the result. Then the area of palm ABCD is equal to norm of AB cross norm of AG. An application about this: consider the points A defined by its coordinates 1, 1, minus 1, and B defined by 0, 2, 1, and C minus 1, 1, 2. The first question is to show that OABC is a biome, and the second question is to calculate its area. Let's remember that to prove that OABC is a biome, we need to prove that the two vectors OA and CB are equal. So let's find the coordinates of the vector OA. We get OA 1, 1, minus 1, and CB also 1, 1, minus 1. Then the two vectors are equal, so OABC is a biome. Now calculate the area of this biome. Apply the cross product rule of area of biome. Then area of biome OABC is equal to the norm of OA cross OC. Now find the cross product of OA and OC. Put them in the form of a matrix. And by calculation we get that OA cross OC is equal to 4i minus j plus 2k. Now let's find the norm of this vector. We get norm of OA cross OC is equal to radical 21. Then the area is equal to radical 21.